Hey students, how are we doing today? We are talking about limiting reactants. This is our last section for stoichiometry. So let's go ahead and jump right into it. Remember to put this title across the top. And here we go. So limiting reactants. Limiting reactants, if we just kind of jump right into our definition, limiting reactants are what stop the reaction. All right, this is what we're going to run out of first. All right. If we think about it, let's say we're making grilled cheese. All right, we're making grilled cheese for the class. We have 20 some kids in the class. I have a loaf of bread, have a thing of cheese, and I have a thing of butter, right? To butter the bread so we can toast it. What are we going to run out of first? Probably most likely the bread, right? And we can't just give somebody a piece of cheese and say it's a grilled cheese, right? That's not going to work. So the limiting reactant in that case is the bread. We're going to run out of that first. All right. Then the opposite of limiting reactant is the excess reactant. And this is what we're going to have left over at the end. So this is going to be left over at the end of the reaction. So when we've been seeing all those questions say excess so-and-so and excess that means we have plenty left over. So there is no limiting reactant in that case, or the other one is the limiting reactant. All right, so how we do this, it is very, very simple. If you're good at stoichiometry, you will be good at limiting reactants. The biggest key here is that we're going to use the same steps, except now we're going to do a stoic line to the other reactant, and we're going to compare how much we have to how much we need. And what we find on the stoic line is going to be what we need. So this is going to be found on the stoic line. So using a stoic line. All right, and the stoic line is the T-chart. So let's take a little look at this example right here. So we've got 2Hg plus O2 gives us 2HGO. We have our molar masses below, and so let's take a little look here. We have 100 grams of mercury. We also have 20 grams of oxygen. So if we kind of write right above here, I'm going to write a little line for have, and then a little line for need. I know I have 100 grams of mercury and I have 20 grams of oxygen. Now what I'm going to do is I'm going to pick one of these, either 100 grams or 20 grams, and I'm going to go to the other reactant to see if I react all 100 grams of Hg, how many grams of O2 do I need? So let's do that. So it's just a handy dandy stoic line. So let's see what we got. We're going to start with 100 grams of Hg. And like I said, this is like all the stoic lines we've been doing all along here. So our first step in the stoic line is we're going to divide by the molar mass of Hg, which we found right there, that 200.59. On top, we're going to put 1 mole of Hg. All right, grams of Hg cancel. Our next step is our mole to mole ratio. All right, so on bottom, we're going to put 2 moles of Hg. On top, we're going to put 1 mole of O2. All right, because that's what we're looking for. We're trying to figure out if I react all 100 grams of Hg, how many grams of O2 will I need to react? And I only have 20. Do I have enough? That's where we're going. So our next step then, I'll get back to my colors here. All right, our next step then is to multiply by the molar mass of O2. So we're going to put 32.00 grams of O2 right there. 1 mole of O2. All right, we're ready to math it up. So we're going to take 100 times 32 divided by 200.59, and then we're going to divide by 2 as well to give us our answer. And this is not going to, we're not quite done, but we'll get there. So let's go 100 times 32 divided by 200.59 and divide by 2. We have 7.98 grams of O2 needed. If we react all 100 grams, let's make sure I did that right. It just feels wrong. All right, but I think we're right. It just felt a little different than what I did earlier. All right, 7.98. All right, so that means if I react all 100 grams of my Hg, I only need 7.97 grams. Do I have 7.97 grams? Yeah, I have 20 grams. So that means I'm going to run out of mercury first. All right, I'm going to run out of mercury first. So mercury, or Hg, is limiting because I have plenty of oxygen. All right, I have 20 grams and I only need 7.97 to react that 100 grams of Hg. All right, awesome. Now, our next step is what I like to do is I like to cross out that 20 grams because we know we have excess of oxygen, right? And we could also find how much excess, right? We could take our 20 minus that 7.97 and see how much we have left, right? 12.03, we have 12.303 grams of O2 kind of left over, right? In case you see a question like that, that's sometimes asked. All right. But now let's look at this last question that we have posted here. It says, using your limiting reactant, which we said Hg was, how many grams of HGO can be formed in the above process? So that means we're going to start, this is our limiting reactant, mercury. So we're going to start our little T-chart with 100 grams of Hg. And this time, instead of going to oxygen, we're going to go to HGO. So we'll divide by our molar mass. It hasn't changed from either yesterday's notes or from above, right? Okay, our next step is our multiple ratio. This time we're going to HGO, right? Probably should have swapped colors here, but we'll be all right. So we have 2 moles of Hg from our balanced equation, and we're going to 2 moles of HGO. Sorry, my HGs are not looking very good there. All right, awesome. And our last step then is to multiply by the molar mass, that 216. So we're going to put 216.59 there, grams of HGO, and this will tell us how much is formed. 1 mole of HGO. Now we're ready to math this up, do some unit canceling. All right. So to calculate, 100 times 2, we could also lose that too, right? Times 216.59, and then we're going to divide by 200.59, and then we're going to divide by 2. And again, we could just go ones right there because they are the same, but it is up to you. So let's do this. 100 times 216.59. I'm just leaving my 2's out. Divided by 200.59. Our answer is 107. And we're keeping 2 decimals, so 98, 107.98 grams of HGO are formed based on our limiting reactant. And that is all there is. All right, I will see you next time.